Now, we can go back to the original problem, the thing we've been trying to solve this whole unit. So, as you remember, we have the sun's rays striking perpendicular to the Earth here at CNA. We assume that these rays all came in parallel, like I've drawn here. And here in Alexandria, which is north of CNA, the rays no longer strike the Earth perpendicular to the surface of the Earth. They strike at this angle, alpha. We showed before that must be equal to this angle, alpha, as well. And by comparing the full angular measure of a circle, 360 degrees, to this portion, alpha, we were able to find that if we knew d and we knew alpha, we could calculate the circumference of the Earth. We got d by timing a camel's distance from CNA to Alexandria. Now we just need to find alpha. To determine this angle alpha, let's imagine what it would be like to be standing here in Alexandria. Well, if I were actually standing there, I can now say the Earth is flat because I don't notice the curvature of the Earth on a daily basis. And I can imagine sticking some sort of pole into the ground. And maybe I know the length of this pole. Now, I know the sun's rays are coming in at a certain angle. I'm going to draw the rays in red just to make it a little easier to see. So here come the sun's rays. You can tell they're being blocked by the pole in some places. So where the pole blocks the sun's rays, we get a shadow. Here's the pole's shadow. And now you can see we're almost there. You can see the right triangle that's emerged. We have the sun's ray that just barely missed the edge of the pole. We have the shadow of the pole, and we have the pole itself, forming a right triangle. Now from this drawing, you can actually see that the angle we called alpha, if I imagine making a perpendicular line here, perpendicular to the Earth, this is the angle we called alpha. That's no problem. That's also equal to this angle, alpha. And now we're almost there. So here's our triangle with three sides, 1, 2, 3, opposite, adjacent to alpha, and hypotenuse. And we just need to know what this angle is. Now that we have our right triangle, we just need to consult a trigonometric table, and we should be able to figure out what alpha is and what the circumference of the Earth is. So we've set up the experiment. We have our vertical bar with its shadow, and what Eratosthenes' data may have looked like was that the length of the bar would have been something around 1 meter, and the length of the shadow about 0.126 meters, which is 12.6 centimeters. He, of course, had access to his trigonometric tables, and here's a portion of one such table. Now, can you put yourself in Eratosthenes' shoes and tell me what is the value of alpha?